Shawn McGuan is the founder and CEO of LifeModeler Inc. LifeModeler is a scientific software company which specialises in the development of software products that are used to simulate motion of the human body. The field of study is called biomechanics, and Shawn McGuan is a 20-year pioneer in this technology. He started LifeModeler in 2002 and has since grown to become a leader in the industry, supplying technology to 5 of the world's top orthopedic companies: NASA, golf club companies, sports shoe companies, government institutions, and many worldwide universities interested in teaching biomechanics in the classroom. Shawn, welcome.
Thank you, Mike. Thank you for having me here.
How did you get started in this industry? It's a fascinating industry and a fascinating company.
Thank you. Well, it started in the early 80s as a mechanical engineer working for one of the top mechanical engineering software companies. The name of the company is Mechanical Dynamics, and they created a product called Atoms. Atoms is used to basically look at mechanical systems and create them on the computer and explore function and how things work. For example, every car in the world has been simulated using atoms. This way engineers can test things out on the computer before they actually pour any metal or build any prototypes or anything like that. So you can imagine how quickly it accelerates innovation. It reduces time to market and really greatly improves the quality of the mechanical system. I mean, that's why we have such great cars today, is one of the reasons, is because of the tools that the engineers have in order to really explore this function. Now, in the early 90s, I looked at this technique and thought that maybe we can extend this to the human being. You can look at the human being, for example, as a collection of parts and joints and forces in the same way as you can a car as parts and joints and forces. So I went on and developed some tools using the mechanical simulation principles to try and approach the human body like this system. Then the next step was, what kind of market is out there for this type of tool? And then I thought, well, it'd be nice to test products that the human interacts with, whether it's inside the human, used by the human, or on the human. And so I went after one industry in particular. It was the top sports shoe company back in the 80s, or they are currently, and developed a simple foot-leg model to evaluate an ankle sprain, like a basketball player coming down on another foot and spraining his ankle. And with the model, you can then adjust the properties under the foot, like change the nature of the midsole of the shoe, and evaluate whether or not the shoe is going to protect the ankle and also cushion the player from shock. It's a pretty interesting engineering trade-off. And the way they've been doing things currently, or at that time, was to build a prototype of the shoe, put it on a guy and have him run on a treadmill, and then he would evaluate how it felt. So it's a very non-elegant way of doing something. You're getting kind of feedback from a person who's going to fatigue over time and may have a bad day and so on and so forth. And the idea with this model was the models never fatigue. They are what they are. They're going to give the same answer in the morning as they do in the afternoon. And then we can try hundreds and hundreds of variations. We can change the way these springs operate under the foot. We can make stiff ones in the front and less stiff ones in the back and things like that. And just evaluate all these combinations without making anything. So by the time they zero in on that design, they've got something pretty good, and they can reduce the number of prototypes and build the shoe much quicker. I took that same concept and worked my way up the leg and said, okay, how about knees? Let's create a model of the knee, a very sophisticated model. Let's add muscles and the contact joints and things that are in the knee. And let's approach an orthopedic company. So again, I went to the top company in the field and presented this model to them to look at developing total knee replacements. And they looked at this as a way to really increase design, because at the time, and really almost still to this day, the way you develop total knee replacements is you have to cast the metal and create the mold for the plastic parts and so forth. And then you have to have a surgeon put this device in a cadaver leg or a cadaver specimen. Then you put this cadaver specimen on a rig with cables and things, pulling the knee around. And then you get some kind of data, some kind of function, how it moves and so forth in the body. As you can imagine, that takes a long time. It's very expensive, and cadaverous specimens, besides being very smelly, do not have a lot of structural integrity. So you come in with a model that's been validated to perform like a human leg would, and let's take out the good human knee and put in a model, or a computer model, of the total knee replacement. And now let's exercise it in a variety of patterns, like walking, climbing up and down stairs, getting in and out of chairs, and then let's see how it behaves. And all this is done before anything is made. It's all in the computer-aided design stage, or the CAD model. And so by the time they're done with these iterations and these design tweaks, they can look at thousands and thousands of design iterations before making any part. So that kind of set the groundwork for this technology. I saw there was a market for it. I continued developing tools and more functions and moving up the body until I had a complete human body model. And then I approached sporting good companies. I worked with the top golf club company in the world to help them develop a golf club that would suit the common man. Now, it's an interesting challenge because you expect them to want to be able to optimize a club for the best golfer, and they do that. But it's more challenging to look at the common man because he's all over the map. It's really hard to characterize what the common man does. And so it's even harder to develop a golf club that has such a range of operation that it can be good for the poor golfer and the good golfer and so forth. So these human body models did the same thing. We had these models would swing these golf clubs in the computer. Nothing was made yet. And they would look at changing shaft parameters and center of mass in the club heads and things like that. These various engineering parameters until they optimized the club for a certain golfer population. In 2002, I was so excited about this industry, I decided to build a company around it. And I was so fortunate because if you can imagine, given the opportunity to go out and grab 10 or 15 of the smartest guys in the world, guys that you've known, some over 22 years, put them all together, work on state-of-the-art stuff that actually helps people. And oh, by the way, let's do it at the beach in Southern California. That's where my company is based, is in San Clemente. And we did that. So we have just a dynamic working environment and a racehorse team. And we spend a lot of time and energy on the culture of the company, making sure that we're ripe for creating new products and new ideas and so forth. And it's just positively thrilling being on the forefront of this.
Let's talk about your products.
Our flagship product is called LifeMOD. And LifeMOD is a full body modeler. And it's used for a variety of things. It's used, for example, we have large contracts with NASA where we explore astronaut activities. And we're answering really interesting questions like, how much gas should a astronaut pack while doing some activity on Mars? It's a simple question, but how do you figure that out? And so we work with NASA on having a subject on Earth climbing in and out of a vehicle, digging and so forth, and then going back in, doing the same types of activities that he would on Mars. And we capture the motion of this person using motion capture equipment. And you may have seen this. This is where they put the lights and things on the body. And they're doing this in front of a series of cameras. And the cameras will track the motion of the body during these activities. We'll then use that data and create a full body model and simulate the exact same activity. So you'll see computer animations of little skeletal guys digging and so forth. And then we'll change the gravity. And that's something you can't do testing, right? So we'll change the gravity down to the Martian gravity, which is a microgravity environment. And then we will have the model do the same activity and then use the muscle forces and calculate the amount of energy it would have taken to do that activity. And so that's one question that you can solve. We're kind of in the business of solving questions that you can't really solve. Another area we're in is safety. We helped a South African neurosurgeon develop a motorcycle neck brace. And this is something you don't want to test prototypes with because you don't want to have your volunteers slamming into the wall. And if you look at a motorcycle racer now, he's got leather and pads and shoulder pads, but you can almost see the skin of his neck. It's that unprotected. So this neurosurgeon's idea was we need to change that because there's a high incidence of neck injuries. And so his idea was to come up with a carbon fiber shell, or kind of a cone structure. And it's a very complicated system. You can't just put a limiter here because you may induce higher forces than if he wasn't wearing the device at all. And so the only way to test that is either by building the prototype, the physical prototype, putting it on a dummy, and then trying to crash the dummy and see what happens with high-speed photography. Those tests are very expensive, and of course it takes a lot of time to manufacture the neck brace and so forth. Now with a human model that's very high fidelity, that's very human-like, let's try variations of this. Let's try the geometry and then crash this model. We're not hurting the model at all. He'll get up and do it again. And by the end of this series, we'll have a very good design that promises to be very useful in motorcycle racing. That is our main product, LifeMOD Body Sim, we call this. We also have several products that are specific for certain regions of the body. One of our most successful products is LifeMOD Knee Sim, which is used by most of the top orthopedic companies now to develop total knee replacement systems. And there's several issues, or many issues, when you're developing these systems, as you can imagine. First of all, you want to have the knee system replace as much human function as possible. It'd be nice if you could give it even more, but you really want to just replace the function. Then you also want the knee to last a long time. You want it to last 20 years if possible. You don't want to have the patient come in again and have a revision and so forth. And then finally, you want to make sure that this device is not so sensitive that it can only work with one type of patient, that it can work with a broad number of patients. And LifeMOD Knee Sim answers those questions. It's able to look at the trade-offs in each one of those areas and work with the engineers and the physicians in helping to optimize a knee component system. And that's really one area that we've been quite notable in. In fact, we worked with one company in particular, Smith & Nephew, in the complete development of the Journey knee system, which is won critical acclaim. We also have products for the cervical spine, the LifeMOD Neck Sim, and we have a new product called Lumbar Sim, which is being funded by the top spinal device manufacturer in the industry to look at spinal implants, disc replacements, fusion type systems, mobile systems, and things like that.
So who are your customers?
Our top customers are the orthopedic companies right now. We're really focusing on that industry mostly because we have the most traction in that industry. Like we mentioned before, NASA is another fantastic customer for us. For example, an astronaut in a microgravity environment, not only will his musculature decay, he'll actually lose muscle mass, he also loses minerals out of his bones. And then finally, his control system, or his neurological system, decays to a certain extent. And so the scientists need to know, how can we keep that intact so by the time the capsule reaches Mars, the astronauts just don't fall out of the capsule. They actually can perform their duties. So we work with various exercise physiology groups in developing new exercise protocols. Then we do the fun stuff with sports companies as well. That's always interesting. We're looking at pitching different support and protection structures for the NFL and things of that nature. It's quite a broad type of base for us, and it's something we really enjoy because it's extremely interesting. And plus, we can apply things we learn in one industry over in another industry. It's amazing how we can cross-fertilize different technologies.
So what about the future?
Well, we have
never ending. I mean, the sky's the limit. Actually, Mars is the limit.
Yeah. I mean, that presents its whole set of challenges. You know, we've basically been doubling our revenues ever since I started the company, and doubling our customer base. So it's really gone, it's grown quite a bit. The challenge really is scalability. How do you scale up to meet this demand and do it in a way where you're not taxing your employees and having them work 100 hours a week, doing it so you continue to hire the best employees that are out there, that you don't cut your standards in order to get a guy in quick, doing it so you can build your infrastructure on your technology and not just come up with a quick solution because that solves the problem. There's a lot of things to consider, and this year in particular, we're kind of reining everything in, and we're doing some things to bring in a large cash infusion into the company and essentially double the staff yet again, so we can sit back and really approach this demand intelligently.
Mm-hmm. If somebody wants to find out more about the company, become involved in the company, how do they do that?
Right now, our website is lifemodeler.com, and we have a lot of information on that website, including videos and past projects and things like that. It's quite interesting and quite educational.
You lead an exciting life, Shawn. Thank you
you
very much.
Thank you.